Hello, and welcome to the Guildline 6625 training video series. Today we're going to discuss the 6625 system, its basic overview, and how it works together as a system, and just basically how to use it. So 6625 is a system that is designed to measure unknown resistances against known resistances to a very accurate level to less than a part per million. It comprises of resistance standards, a series of 4-terminal resistance connection switches that allow you to hook up to 32 different devices, and they can be intercompared through the heart of the system, which is the bridge itself. And over here, outside of the rack, we have a range extender, which allows you to generate up to 300 amps of current for measuring low-value resistances and shunts. All this stuff can be connected through the wires provided in the system and various types of adapters to allow connections to different types of resistors, such as things like 4-terminal resistances here, Heyman type standards like SR1010s, 2-wire devices, and even decade boxes, such as this one here, which is a 2-wire connection. Now, I'm going to discuss each of the sections of this and how they play a role in the system. Starting up here at the very top of the rack, we have the resistance standards. This one here is a 6634A resistance standard, which is essentially 10 different resistors, or at least up to 10 different resistors, inside a temperature stabilized oven chamber that maintains the resistance values to be very consistent and accurate. Here in the front, you'll see that there's a connection as well. This allows you to actually monitor the temperature of the chamber inside here, which is set to usually about 30 degrees above room temperature, so that way the heat inside the rack and other things don't affect it. It's also sitting in an EMI shield, so that way there's no radiation effects or anything else as well. Okay, so you see over here, the heater light will cycle on and off, and that's just letting you know that the heater inside is controlling the temperature and regulating correctly. So down below the resistance standards, these were your working standards, what basically would be the references for your lab. You'll have a set of 4-terminal switches, and this allows you to connect any of these resistors or resistors shown outside of the rack to either both the RS, which is the standard side of the bridge, or the RX, which is the unknown side of the bridge. Essentially, the scanners work in a fashion where you press in line A, which is RS, on either the scanner down here or the scanner up here. This represents channels 1 through 16. This one represents channels 17 through 32. And you would press the RS, and then say I want channel 22, and then lights will come on indicating that that channel is selected. And for RX, the same thing. To clear any of these channels, you just press the button and you see that the light turns off. The other thing about these scanners is they're connected in a fashion that this scanner is aware whenever a channel is selected on this scanner. So if I were to have channel 18 selected here, I cannot select channel 2 to RS. Only one resistance element can be selected on RS, and only one can be selected on RX. So consequently, if I had channel 24 selected to RX, I cannot select an RX channel down here. If I clear it, now I can. And that's a safety precaution so that you don't end up making some kind of measurement where you've connected 2 resistors to one side of the bridge and potentially damaging your standards. So down here is the 6622A resistance bridge, which is the heart of the system. It is a device that compares an unknown standard with respect to the known standards here. Essentially, it is controlled through the screen down here and a series of soft keys with key navigation and keypad entry. The menu itself has 3 main sections. You see there's measure, setup, and soft cal. Primarily, you'll use the measure and the setup menu as they represent the functions used for day-to-day measurements. The soft cal is used for basically maintenance and any diagnosis. So when you press any one of these soft keys underneath the menu item indicated there, it does that function. So when I press measure, now I'm into the measure menu. Anytime you would see something where you see the 2 lines with a space between them, it basically tells you there's a menu underneath it. So if I was to press this, I'll go into the view menu. And you can keep going back and forth through all these different menu systems. And pressing previous will go back to the menu you were in before. So whenever you've gone too far into a menu, if you're not too sure where you are, you can always hit previous enough times and end up here back at the base menu, or you're back to measure, setup, and soft cal. So also inside here, you can see that there is this thicker line here, which says basically it toggles through different functions. So you can display the value in ratio or ohms in this example. And when there's more menu items in a given area that can be displayed on a screen, you'll see that this appears here more 1 of 3. So that means there are 3 different sets of menus here that you can choose from. And it just cycles through all the different 3. And this gives you all the different functions and abilities on this screen. And again, you can hit previous to come back out. Also, when you get into menus here where you can do numeric entry, you would, for example, press edit, and you can see the highlighted cursor comes here. Now the cursor can be moved around with the arrow keys and allow you to type in whatever values you wish here. And cancel will basically not load the entry that was given. And if you hit previous, you can back out and just keep going back. Over here, outside of the rack, is a 6623AF range extender. It's a 300 amp range extender, which means this device here can produce up to 300 amps. And it's usually used for measuring low value resistances such as shunts. So typically these values are below 1 ohm. The range extender itself has no front panel interface, as you can see, other than just a power light and a fault light indicating there was some kind of problem with the measurement. The entire interface of this is actually built right into the bridge. There's a cable in the back that connects the two, and the entire control of it, including how much current is being set, when the polarity is being reversed, what ranges you're using, and all of that capability that exists within this device is controlled directly on the bridge. And of course, in the center of the entire system, when you get into software, there is a laptop inside here, inside a convenient drawer with a mouse, and basically runs the Bridgeworks software, which we'll get into discussing in the next segment of the video, which allows automation of all these devices on a single interface. It can conveniently be stowed away when not in use. Other peripherals to the system, of course, there's a large amount of wires that come with the system, which allows connection to all the channels in the scanner not already set up with the 6634 that's built into the rack. And this adapter here allows connection to SR1010 and SR1030s and 1060 standards and other type payments. Here's an example of an SR1010. These are commonly found in a lot of militaries, very widely used. And this device basically allows you to connect it straight on, just like that. And then you can measure the whole thing and it'll scan through it all and do it completely automated. It saves a lot of manual work, and that's the whole point of the system, is to allow processes to be automated and allow for less manual intervention to help speed up the processes. So the system, things like this SR1010 adapter and many of these channels, and the channels here for the 6634, are already pre-wired in your system. As an example, your 6634 is connected from channel 17 through 25, starting with 1 ohm. So you have a 1 ohm, a 10 ohm, a 100 ohm, 1K, 10K, 100K, 1 meg, and 10 meg. And this one here is a 0.1 ohm. So that's a tenth of an ohm. This is set up in a fashion so that all of your main standards here are working, your working standards are basically in decade steps up in this area. This section here of the scanners is actually a high current section of your scanner where the red wires are. In this area here, that's why the 0.1 ohm is there, because you can drive the 0.1 ohm to a much higher current than 100 milliamps, which most of these channels are only rated for 150 milliamps. These ones here can take up to 3 amps. This channel's down here. The first 12 channels are actually connected to a device over here known as the SR1010 adapter. So that represents for all 12 elements that are in an SR1010, and it's hardwired to the back system. The reason for all of this and using all these channels is that all these wires are connected for you. And when you connect a lot of these wires and all these elaborate setups, you can have high probabilities of different errors. But when it's pre-configured and it's semi-fixed configuration, which is what we call it, then all your main points, such as your resistance standards and devices like this, are already pre-configured, pre-wired. You never have to change them, and so they have a very minimal chance of failure. And that just produces better consistency with your results. We're going to discuss a little bit on how the actual resistance measurements takes place inside the bridge, just so you have a basic understanding on how this device actually works. As I mentioned earlier, it basically transfers a known value to an unknown value, and how this does that is through a ratio comparison. And a ratio comparison is done through basically a transformer, where you have a primary side and a secondary side. The primary side is where your reference resistor is connected. It has a certain number of windings, and they're fixed, and they do not ever change. And it is partly why there's such permanent accuracy in the bridge of less than a part per million. On the secondary side of the toroid, the windings are switched, and you can basically switch in any ratio you want, anywhere from 1 to 100 to 100 to 1. So it's a very wide range. So putting this into an example, if you had a 100 ohm resistor, you could measure all the way down to 1 ohm, compare it against this 100 ohm resistor, or you could measure all the way up to 10K ohms, compared against that 100 ohm value, and this would give you accuracies of less than a part per million. This is done through either driving voltage or current through both resistors on both sides of the transformer and switching the windings until you've reached a balance. And the balance is determined through a nanovoltmeter. Summing up the resolution of the windings in the toroid and the nanovoltmeter's linearity, you have up to 32 bits of resolution, which results in 0.001 parts per million resolution. And that is how the bridge makes a measurement. So the bridge does all the switching of the toroid, as well as the polarity reversal for either voltage or current, depending on the mode you're in, to make the measurement as simple as possible. All this is done and controlled by the internal workings of the bridge itself. This switching system, along with the nanovoltmeter and the permanent accuracy of the toroid, basically gives you a resolution of down to 0.01 parts per million and an actual accuracy of 0.1 parts per million.